Hello everyone. Can you hear me loud and clear? Please let me know in the chat. Welcome to another GitHub virtual meetup. My name is Martins Ewere, and I'm a Nigerian American living in the Bay Area, living in the San Francisco Bay Area. So I'm really excited to have everyone come join us. Also, let us know in the chat if what country around the world you're from, and so we can get to know our audience even much more. So thanks again for joining us today. We have an exciting lineup for you today. Specifically, we'll be having a focus on DevOps, and a lot of speakers are ready to talk to you today about DevOps and how you can get started wherever you're based. So let's get started here. All right, let me share our agenda for today. So for today, we have, like I said, we have a lot of things set up for you today. We have my welcome address, and we have our very own Sasha Rosenbaum. She's a senior product manager here at GitHub, and she will be talking to you about introduction to DevOps, and also throughout the talk, we have people coming to talk about. We have Cobus Bernard, who will be talking for 20 minutes on an introduction to DevOps on AWS. And then we have our very own Brian Douglas. Brian Douglas is a developer advocate here at GitHub, and he'll be talking through how to automate tasks using the GitHub API. And after that, we have our another guest from Nigeria. Her name is Anita Ihuman. Anita will be talking about GitHub Actions. And after that, we have Maye Edwin. Maye Edwin will be talking about GitHub Packages. And after that, I will have a closing remarks and some exciting announcements. So make sure you stay to the end to hear what we have for you, guys next. At our next closing remarks, we'll have a breakout room where we can answer some questions that you guys have and go through any things you're thinking about. So before we dive into the first speaker, I would like to point you guys to our product roadmap. As you already know, we've announced a couple of times, we have a public roadmap currently, and you can go to github.com/github/roadmap to view all of our roadmap and the things we're working on, and some of the things we'll be announcing next month. Specifically, one of the products I'm really excited about is our GitHub Code Spaces. GitHub Code Spaces basically is an integrated development environment on the web, and it has a ton of functionality. You have an editor there. You can connect your source code on GitHub, and it also has a terminal. So definitely go check out the roadmap to see all of the cool things we are building at GitHub. And with that, I would pass the baton to our very first speaker, Sasha Rosenbaum.
Hi, everybody. I hope you can hear me all right. Sounds like you can. Hi, Martins. Thank you for the intro. Let me just share my screen so we can get started. All right. So, I'm Sasha Rosenbaum. As Martin said, I am a product manager here at GitHub, and today I'm going to be talking about Intro to DevOps or DevOps 101. So I really wish I could see you all so I could ask you what you do for a living. So are you a developer or are you an ops person? Or are you just getting started or any other walks of life like security or QA or anything like that? But I'm just going to have to assume some type of level set and start from the very beginning on what DevOps really is. So let me make sure that my clicker actually works. So that will be helpful. A little bit about me. I started my career as a developer about 15 years ago. That really was that long ago. I can't believe it myself. And then I was working as a consultant for a cloud company. And so we're building infrastructure as well as applications. So I sort of gradually started getting involved with operations as well. And then I was a cloud solution architect for Microsoft for about 5 years. And then I am now a product manager for GitHub. So this is a story a little bit about my career. So what is DevOps? You might have heard the word, and you might have heard many people ascribe different meanings to it. There's really not a lot of agreement in the industry about what DevOps is. So I'm kind of going to get started with where it all started from. So every company today is becoming a software company, right? There's a saying that software is eating the world. So really every big company is now transitioning into offering major software offerings, or they're getting disrupted by someone who is. And you used to be able to just make car tires and sell car tires and not have any web or mobile presence and be fine with it. But today, that's really not a possibility anymore. And there's this big difference in software that we used to say that you could either have speed or you could have reliability, right? And these two didn't work together. So either reliability and quality or speed. And what we are beginning to learn is that these two are not actually opposites. They actually work together and go hand in hand. So the word DevOps was actually coined by two people who came together in 2008 at Agile System Administration Conference and started talking about how we essentially say that developers and operations are on a different side of the spectrum here. So developers just want to push to production as fast as possible and deliver new features, and operations just want to keep the lights on, make sure nothing breaks. So they want to prevent developers from pushing to production, right? And they basically agreed on the fact that this is not how it should be, right? Because in the end of the day, all of our goals are the same, right? We want to deliver application to our customers. And so the goals are the same. I stole this slide from an earlier presentation by Bridget Cromout, and I'm keeping it as it is. But this is how the first DevOps Days conference was born in 2009 in Belgium. And now we're basically at the space where there's like 150 different cities doing DevOps Days, including, I think, Cape Town and some other places. And so this became a trend, and it also evolved into where DevOps is used by a lot of people to mean a lot of things. So I'm going to give a definition. There's many definitions. This is not the definition, it's a definition, but DevOps is a union of people, process, and technology to enable continuous delivery of value to your end users. And notice that I'm not even saying software, I'm saying value, because this is really what we're doing, right? We can deliver software all day, but if it doesn't solve problems for people, we're not really doing anything. And it's not really just about technology or just just about culture, but it's about all of these things. And now we know from research, actually, this comes from DORA reports, and Nicole Forsgren actually works for GitHub now, which I'm really happy about. This comes from DORA reports, State of DevOps, basically that highest DevOps performers are actually both speedy and reliable, right? They have much, much higher deployment frequency in multiples, in like hundreds of multiples, right? They have faster lead time from changes from idea to production, but they also have a much lower failure rate and much faster times to recover from any breakages. So turns out this like continuous deployment thing is like a muscle. The more you do it, the better you get at it. So to explain this a little bit more, I would like to introduce another acronym, and that is DevOps Comms. So there's this really famous book. It's called 5 Love Languages, and it's about relationships and how to be successful at relationships. And it talks about how really the reason we don't understand each other and the reason we have communication problems so often is that we all speak different languages. There's 5 main languages that people have, and we try to communicate with each other, but we are not necessarily speaking the same language, and that's where problems get started. And so I want to bring this as a metaphor and say that there's really 5 love languages of DevOps, right? So there's comms for culture, automation, lean thinking, measurement, and sharing. And really all of these things together comprise the DevOps mindset that we are as an industry really obsessed with. So let's start with at the beginning with the culture. So really, like I was talking about, a lot of companies used to have everything in silos, right? So development is incentivized for one thing, ops is incentivized for another thing, QA is a separate department. All of these things are working sort of against each other, right? Just throwing tickets across the wall and not really communicating and kind of treating each other like an enemy. And this is not what we want. So for instance, in our industry, we learned that we used to separate all of these things, right? So QA was separate and development was separate, program management was separate, and so on. Then we added like SRE and they were also separate and stuff like that. So basically what we learned is all of this creates this lack of sense of ownership, and it's everybody else's problem, right? It's QA's problem that the code is not working. No, it's back to developers. Now it's their problem that the code is not working, and so on and so forth. So we learned that what is much better is actually to create a collaborative sense of ownership and have a feature team, right? So you actually have this feature team that is, I think I have automated timings, which is a great win for this. Okay, this is fine. So basically, instead of having vertical teams, we're now having horizontal teams. So instead of someone owning the UI and someone owning the API and someone owning the data, and they barely speak to each other, we have vertical teams. And we have discovered that once everybody cares about delivering that customer value, everybody is actually better about collaborating with each other and working together to accomplish things. So what about the next piece of it? And that's really another core piece of it. And I'm sure in Cobus's presentation, he's going to talk mostly about automation, right? So we have automation as a core piece, core love language of DevOps, right? And when we speak about DevOps automation, we mostly speak about something else, which is relates to continuous delivery. So to quote Continuous Delivery book, which was also published about 10 years ago, asking experts to do boring and repetitive and yet technically demanding tasks is the most certain way to ensure human error that we can think of, short of sleep deprivation and inebriation. So basically what they're saying here is that we are constantly, before we had CI/CD, before we had DevOps, we were constantly asking operators to go through these checklists and basically work with these long automation procedures. You need to do this and you need to do that and you need to do XYZ 25 other items, and this is repetitive and this gets manual and people miss things and it creates problems, right? And so instead of that, we started venturing into the world of CI/CD or continuous integration and continuous delivery. Now, when it first came out, people actually said like, nobody can do this. And now basically everyone is doing this. So what really is CI/CD? CI/CD, continuous integration, stands for building and testing on every change. So every time I commit code, my code is built and tested. right? And it today to us sounds kind of very obvious, right? This is what you should do. But it's not how people used to work. People used to work on their own laptop for like 2 days or 2 weeks, and then work in their own branch for like 30 weeks and stuff like that, and only then go through merge hell in the very end of the process. And then continuous delivery is taking it a step further and saying that I can deploy any successful release candidate. So any code that passed my automated tests, and for that automated test actually needs to be pretty good. Any code that passed automated tests, I can now deploy it to production. Right? It doesn't mean that I have to deploy every change to production. That would be continuous deployment, which confuses a lot of people. But continuous delivery means that I could, right? So everything is committed back to the main branch, and there is some type of gate, some type of process that you can click a button or have another piece of automation that's approved by somebody or approved even by automated process. And then once every check passes, we can deploy any change to production. So for that, of course, at GitHub, we have GitHub Actions, which are one of the world-class systems for CI/CD and other types of automation. So you can really automate almost anything with GitHub Actions, but we're seeing lots and lots of usage of GitHub Actions, primarily for CI. So we literally have millions of uses a day for people building and testing their code repositories every day on GitHub Actions. And there's going to be another presentation today by Anita about GitHub Actions. So I'm not going to steal her thunder, but this is a pretty cool product. And if you haven't had a chance, you should look into that. I am just going to show like just a couple of another slide. So just this slide, which is basically what I can set up with GitHub Actions is set up a workflow that triggers on every push and pull request. And this is really what comes to mind when we're talking about continuous integration, right? Every time I committed my code, I am going to build and test my code, right? And then I can really, if I go into Actions tab into any repository, the first things that are suggested to me are actually workflows for CI/CD. So you can see that this suggested workflow actually goes through building and testing your code, and potentially, so this is a node module, so potentially actually committing that in pushing this into NPM. So basically, this is one of our biggest suggested uses for GitHub Actions, which is taking care of your DevOps automation piece. And then again, another thing that's really, really important for CI/CD and DevOps and being able to push to production on every change is trunk-based development. So essentially, everything that we do actually gets pushed back into the master branch all of the time. And a lot of times people ask me, well, how can I develop a feature for 3 months if I am not ready to deliver it to customers? And to that, there's an answer, and that is that your aim won't be perfect. So you need to protect yourself and basically need to prepare a way to control the blast radius for any change that you push. So how do you do that? Well, so the industry standard today is to have feature flags, right? So one of the things that you can do for progressive releases, and that's not the only one, but it's one of the things that you can do, is enable feature flags. And in GitHub, we have feature flags both on your side as a user and also on our side as a product, right? So as a product manager, I can actually go and enable a feature for a particular user. And as a user, you can also go into this feature preview and find some features that are not enabled yet that can be enabled. So we develop these features under feature flags for potentially months. And then once we're ready, we push it to customers. And that allows us to continuously push that code and test it all of the time, right? So it's not one big chunk of code that gets deployed to production in one blow. It can potentially break a lot of things. The next thing that I want to talk about is lean thinking. So COMS, lean thinking. And that really pertains to eliminating waste and like building a minimal viable product and then pushing to production and learning from your customers, right? So for that, we really want to iterate over pain. So when you're first starting your journey, everything looks overwhelming. Like, how am I going to automate all the things? And how am I going to get from pushing every 3 months to pushing every day? Like, this seems incredible and insurmountable problem. But really what you do is do these little changes every day that enable you to get better and better at something you do. So For instance, in one of our products, we had long-running tests that were running actually longer than 24 hours. And you can't really push to production every day if you have tests that are running for 24 hours, because that's more than a day to actually approve a change, right? And so we took our time and actually started getting these tests into where they could run automatically in under 10 minutes. But that really wasn't a concentrated effort that happened in one day. It was an effort that happened over almost 3 years of time, where every sprint we took a few minutes or a few hours to work on these tests and to make them better. So the next up on this journey is measurement. So it is really important to measure things, and it's really important to measure what's important, right? So I like to talk about what we measure. So we measure usage and user churn and customer acquisition. We measure time to build and time to deploy and all of these things. We also measure lifesite health. So like, how long does it take us to detect an incident, and how long does it take us to mitigate an incident? Actually, my favorite thing on here is what we don't measure, right? So we don't measure if we met the original estimate. If we discovered new things and it actually took us, I don't know, 3 months longer to deliver a feature, that's just because we built a better feature in these 3 months, right? We obviously don't measure the lines of code that anybody commits, right? And we don't measure velocity, number of bugs found, and stuff like that. These metrics actually drive different behaviors than what you want. They drive basically people gaming the system. And whatever metric you set, there's always going to be people gaming the system to meet that metric. So I like the metric of customer satisfaction, because if you can game customer satisfaction, like, take it away. Just please go do it. I want to learn from you, basically. And then another thing that pertains to measurement is how we got to this evolution of done, right? So the most immature thing here is that it works on my machine, right? I'm a developer, it compiled on my machine, it must be good. Then, okay, I can merge it into a long-living development branch. My branch still lives in development separate from production, but I can at least merge it in there. Then we get into like, okay, I can actually evolve to merge it all the way into the main branch. Then we evolve into it actually passes all automated tests. And then we got into, okay, it's live in production. And you would think that we would be done here, right? So done live in production sounds like a pretty good metric. But really, there's another piece to it that is actually important, and that is live in production and the customers are happy with it. So if we actually deliver the feature and there's lots of customers that are not using it, or customers that tried it and didn't actually like it, then we actually did not deliver value. And remember, the measurement that we're going for is delivering value to end users, right? So the real metric that we want to look at here when we deliver software is live in production and our customers are happy with it. And then the last but not least piece of it is sharing. So GitHub was really born out of sharing things, right? We're all about community. We're all about collaborative software development. And sharing really pertains to a lot of things, right? It can be about sharing knowledge between people. It can be about sharing code between people. It can be about doing blameless postmortems, or starting with the why of the change instead of just telling people what to do and telling them the how of what to do, right? So there's lots and lots of things that go into collaborative software development, but really the more of it you can do, the better the world gets. And then the other thing I want to mention for sharing is that you can now support your communities with GitHub. You can support projects that you like. You can sponsor people that develop open source projects that are important to you. And you can also potentially make money if you're developing a project, an open source project. People can sponsor you as well. So I think this is a really good way that GitHub is enabling people to share their code while essentially being able to also pay their bills, which is important. And the journey of 1,000 miles always begins with a single sprint. And DevOps isn't magic, although it sometimes looks like magic. And thank you so much. I am Sasha. I can be found on GitHub and on Twitter as DivineOps. And please feel free to ask me any questions that you have.
All right. Thank you. Thank you so much, Sasha. That was a wonderful introduction to DevOps. I really like the 5 love languages analogy. That was pretty cool. Thank you so much. So our next speaker is Cobus Bernard. Cobus Bernard is a senior developer advocate from Amazon Web Services, and he'll be talking about introduction to AWS and how to get started there. So I'll let Cobus take it over. Thank you, Cobus. Over to you.
Cool, awesome. Let me quickly get my slides ready. And I need to swap them. Let's just double check. That. I hope you should be able to see my slides by now. So just a quick word here is that initially when I did this talk, I had a couple of demos on how to automate things on AWS and also to explain AWS a bit more. And then I looked at the lineup again for today's session, and I kind of felt like I don't want to do a sales pitch for AWS. My role is talking about AWS and AWS tech. So you will get my contact details at the end. There are a lot of things that I can show you, but I felt let's talk about something a little bit more interesting, I think, at least in the context of today's talk. So this is where I make the organizers a little bit nervous. Sorry about that, but I basically changed my title from DevOps on Amazon to DevOps at Amazon. Because I thought this is actually a very interesting story. It touches on a lot of the core components that you need to actually do to actually get a successful DevOps strategy going at a company. And thanks very much, Sasha, for the intro there. It helps set the scene for exactly, no, it's not just a tool, because someone's probably trying to sell you something if that's it. Cool. So what are we talking about Amazon? You might have seen a page like this. I actually took the screenshot just before I started today, and this is what the current web page at least looks for me. And this is nice. There's an inbox, there's accounts and lists, there's a whole bunch of components to this, and this kind of looks like a nice, smooth thing. But this is not how things started. Way back when Amazon started in the 90s, this is what the actual website looked like. And as you can see, this is an absolute beauty. The focus was on selling books online. And as you can see, well, it says Amazon.com books. That was the focus. So this is where we started. So how do we go from this to this? Well, let me take you through that journey a little bit. And just quickly before we get into all of this, just a little bit of a warning. We are not going to be talking just about tools. There is a section that we'll be talking about people. People are very important, and often the longer you spend time in software, the more you realize that most problems are actually people problems and not technical problems. So a little bit of background about me. I've also been a developer for about 15 years and 3 days to be exact since I started my very first job. And also it's been 15 years and 2 days since I had my first database production break. Do not ask me why they gave me production DB access on day 2. It's a lesson I learned, and I didn't do that again. I also organize and co-organize the DevOps Days Cape Town conference once a year as part of the broader DevOps Days group. So if you're interested in DevOps, definitely head over to devopsdays.org. Great site to see where the local ones is. Obviously, with the current situations, there aren't as many in-person events, but there are still some virtual ones there. And then also just a fun little fact is that picture at the bottom is actually what my roof looks like. And unfortunately, the Google Maps satellite view is not as accurate. So you can't really see the Space Invader on my roof, which is a lot of fun. Cool. So also, I'm based out of Cape Town. AF South 1 is the newly launched region from AWS in Cape Town, which is why that part is there. So where did Amazon start off with their whole journey in terms of building things? Well, they started off pretty much the same way as most other companies, with a fairly typical 3-tier architecture. You've got your web servers, you've got your business layer logic, and then there's some kind of database at the bottom. And this worked, and they were building things, and then they started hitting some scaling bottlenecks. So you know what they did? They went and looked around. What are people doing? What's happening? And the first type of scaling that happened was that we started sharding our databases, because there was a distributed computing manifesto that came out, and a couple of people starting to figure out, this internet thing, how do we handle big traffic? And the first thing you do is you take your database, which let's say one big database like this, and you take some of the tables and split them off into different databases, because then you can actually have some service calls go to the one, and you can make it a beefier server if you need to, and other calls go to other database services. So that gave us a bit of a headroom. And at this point, we still had a monolith. And the interesting part here is that the monolith application actually had some parameters that you could feed it at startup. And depending on those parameters, it actually behaved in different functions. So you could, for example, have it function in a order dispatchment service in one case versus the actual serving the website in another. But it was all a single effective application that you started up. It just had different aspects depending on these parameters. So we had a nice, big, chunky monolith. And then what happened is we found that we're starting to get slower and slower, and we can't get features out. It's starting to get a bit harder to get features out. So what happened is that around 2001 to 2002, we started breaking down this monolith into microservices as they are known now. And also we started adopting a thing called 2 pizza teams. And the reason we did this is that we learned that we want to start decomposing for agility, because the thing is we wanted to start going faster and faster. And the more you actually have to coordinate between multiple different teams, we found that that slowed us down. So how do we go about actually breaking things down? Well, the first thing we did is that we started off saying that break things down into smallest units as possible, like primitives, like this is a single service that we can deploy. And then what that ended up allowing us to do is that we had these different services effectively. And then inside them, we actually had data domains. And when we started mapping those out and started building services around them, we decided that when we do these and we start focusing on the decoupling of the services, we're going to focus on the scaling factors and not the functions. So when you implement these, not everything has to be an event-driven application. It's think about where it makes sense to actually implement something like this. Now, what we also then found with this thing is basically that we wanted each service to operate completely independently, because we found that communication between too many teams is actually terrible, and we're going to dig into that a little bit. Now that we had these individual services running, the next step that we did is that we found that we needed to know exactly how to interact with each service. And this is where we started building APIs between all of them, because one of the things you might have heard about Amazon is that if you've got service A that accesses service B's database directly and not through an API, that's not something you want to do if you want to be successful with Amazon. And that's still true to this day. The reason for this is that when I've got, let's say, 2 database tables, and I've got service A connecting to database B, it means that if I want to change that database B, I need to know that service A is calling it and also go potentially edit service A. Whereas if it goes through the API, it means that that's the contract and I can make changes to the database as long as the API stays the same. And if I do make API changes, there are ways to actually keep track of who actually makes those calls. So that's one of the things. And this also then interestingly led to changes in the actual organization. And you might have heard the term of 2 pizza teams. And when we refer to this, we mean we split our teams into small enough teams so you can feed them with 2 pizzas. But we're not that specific. What size pizza? Is it a small? Is it one of these massive ones that you can't wrap your arms around? It depends. The reason for this is that you want to have a smallish team to be able to own a service. And also, it means that there are not that many people in terms of the communication paths, as we'll look at soon to deal with. The reason for this is that that team can then have the autonomy to actually make their own decisions. What is best for their service? How do they go ahead? There are obviously some constraints around this, like you can't just go and change an API as you want, because guess what? Downstream consumers will have things break. But basically, these teams were optimized to be very closely knit to be able to communicate effectively with a small number of people inside the team and get things out quickly. And we worked on enabling them. And this basically led us to reorganizing a little bit. And what this meant is that each team actually owned everything. And by everything, I mean the planning, the security, performance, that whole list that you see over there, everything from beginning to build your service through to capacity planning, through to actually deployment and all of that. So then the typical question that comes up is that how can one team do all of this? Because we're not talking about a couple of individuals in a team. And if you think about all of these different skills, this is actually quite a lot. And before we get into that, just quickly on the team size and communication paths. For those not familiar, let's say I've got 3 people in a team and they need to communicate with each other. There are 3 communication paths. Whereas if I've got 5 people, there are quite a few more communications paths between this. And this is actually it's a very simple mathematical formula to actually calculate. And as you can see, every time you add one more person to the team, you add a lot more communication channels. Now you can imagine all of these different communication channels by the time you get to 20, 30, 40 people in a team is going to get complex. So that doesn't work. So that's why we went for smaller teams. Now, getting back to how we did all of those different things to be able to get our service up and running and out there. So when we think about the different tasks, we tend to look at them in 2 different ways. The first one is a task that's separable. So we can actually split it in smaller chunks and have a specific person work on one or more of these individual tasks. Whereas other things that are complex tasks require the whole team to work together to come up with a solution. So think, for example, designing your API. That requires the whole team to sit and work together and figure out what it is, what we're going to do, how we're going to expose it, what are the parameters, the methods, etc., and all of that. But once you've actually agreed on what the API is, then splitting it up into individual methods and having different people work on that you can do on your own. That doesn't require as much of a group thought. So then it becomes, okay, how do we build up a team that can do both separate and complex tasks across all of those different domains that we showed you? Well, the answer to that is to quickly take a look at how you compose your team and how you build them up. So the first thing is, let's quickly take a look at what kind of skills the person has. Now, let's say we have a person in this case called Adam. He's got the following 5 skills. What they are doesn't particularly matter in the sense, it's just the example that I'm going to be giving you. The important part is when you compare them and build up the rest of, for example, the team, you start looking at what skill sets do you have across the different team, because each of these individual people, you can see has an ability of 5, 4, 3, and this is purely based on the skill set that they have. But when you start combining them, you can see that by combining the 2 strongest people, you get 6 unique abilities in terms of what they can build. But look what happens if you did stack what you could think of stack ranking and look for the 2 weakest people out of these 3 based just on the ability count. Guess what? You've got a higher ability inside that team. So when you need to think about building up your team, think about diverse skill sets, think about how you can bring people in that complement each other. There's some overlap in skills, but also they bring in different skills. And that's how you start scaling out the individual teams in terms of being able to get to all of those tasks. But still, if you start looking at, for example, just the one person, even with all of these different skill sets, you won't be able to necessarily cover all of those responsibilities that you typically need to be able to run a service. So this is where Werner Vogels comes in and said, well, if you build a service, you run it. And this means that you own it end to end, which also means that you have to deal with the pain. And this is where a lot of the DevOps culture comes in. Because I had a nice chuckle there with Sasha's example of X number of days before merging. I actually worked at a company that had teams that just did mergers, nothing else, day in, day out. We would have 6 to 9 month projects. At the end of that 6 or 9 months, because there were certain windows for merging, you would commit your branch and send it off, and there were these teams, and they would take something between 26 and I think 50 different branches, take all of them with 6 to 9 months worth of code and actually merge them into a single code base, and then they send you back requests saying, listen, this merge was a little bit weird, how does it work? And as you can imagine, things got really interesting when you try to figure out where problems were with that kind of code base. But if you're dealing with that kind of pain all day long, you sure are probably going to spend some time to automate and make it a little bit better. So let's quickly look at that list. Well, when I said the team is responsible for everything, what we actually meant is that they were responsible for their product. And when you look at the circle on the right, you can see that there's a whole list of things that are common to most of the service teams in terms of what they're building, development tools, CI/CD, monitoring, security, etc. Those are tools that they use and consume, but they don't build those tools. They actually just use them. So we've got a lot of rich tooling internally at Amazon and AWS that we actually use to do it. But the teams themselves, there are ways they can contribute to those tools and actually improve them if they wanted. But basically it boils down to is you use these tools to actually focus on building your specific service, which is your product that you're working on. Which means that, yes, you're responsible for everything, but with a caveat and a little star to it. So under this, what we've realized is that, things were going better and we were releasing code a lot faster. And we found that, we want to do things even better. And this is now around 2009. And just quickly, a screenshot of what it looked like roughly. The service map just for Amazon retail at that point is, as you can see, there are quite a lot of things going on there. And what we found is that we started doing a study to figure out where are the inefficiencies that we can actually fix to actually apply and make things better, because we're still releasing code too slowly for what we thought. So what we did is that we started analyzing. We figured out that the biggest challenge was that we were waiting. And by waiting, I mean that we were waiting a lot between commits, between builds, between deploys. The reason for this is that, remember, this is still 2009. We had internal processes where we would fire off emails, log tickets, do those kind of things to get specific builds done or multiple builds bundled together to actually then do some kind of deployment as a group of features. Also, if you wanted to release to production, there was a manual process where you requested someone. And that actually ended up being a very, very big bottleneck for us. It took us weeks to get code out from when you start writing the code to ultimately deploying to production because of all those manual steps. And obviously, that is slow. That is not a good way to do things. So what we did is we said, well, we want to take this down to hours. We don't want to wait days anymore or weeks anymore for this. And then the fun part came in, like how we did this. And this is where I felt the talk actually ties in a little bit with what other bits are coming up later today, is that we're going to be talking about pipelines, GitHub Actions, package management on GitHub, etc. And the thing that made it possible for us is by building pipelines, because this actually allowed us to go faster and safer. And also it simplified things and standardized the way we did it. So all of those tools and responsibilities I showed you earlier, a lot of that is encompassed by the pipelines and the way that we actually ship our software and actually build it. And also the other benefit is that we're able to visualize where we are in the development cycle and release cycle with individual parts of the system, which is important, as you'll see with what we're looking at, how we build this out. So let's look at the actual automation that we did for these specific systems. Now, what you would see there is that for example, the developer would work on a small set of changes, and they would be working, and ultimately once they're done committing that to the main branch, and then there would be some kind of fully automated system that takes over and does things. Now, when we break this down and we start looking at the different stages, there's the development stage, which is I'm writing my code for my feature, and there the focus is on speed is critical. How can I enable the developer to be able to develop features as quickly as possible, quick feedback mechanisms, all of that. Once the code is done and it's of the developer is happy and the team is happy that it's done, how do I get it to production? And as soon as you go from the developer side into the actual other areas where I'm deploying it, then all of a sudden the focus is no longer on speed, but the focus is on quality, because you don't want to release bad quality code. So the way we did that is that we started splitting things up. So let's quickly dig a little bit into this in terms of how we went about splitting this up. So on the developer side, what happened is that you've got this typical flow of the developer would develop on his workstation or her workstation, and they actually, each person has their own AWS account to play around with and actually develop in, and they can do pretty much whatever they want inside that account to test and make things work. Then what happens is that it goes through a code review, because you definitely want someone else to at least look at your code. You shouldn't be committing code just, I'm a great developer. It works. Of course it works. No, you want someone else to at least look at your code and make sure that it is of sufficient standard, etc., before it goes into all the automated pipelines. And part of this is that the developer also explicitly defines the dependencies. The reason for this is that we've got some systems that track the different dependencies between the different systems, and actually allows us to figure out which ones are being used where, so that if we have to make a call, for example, dependency A needs to be upgraded, what is the impact in our system? So we can actually do that. And then ultimately we publish a change state for review, and the team says yes. And this process needs to be fast. We want to get this done as quickly as possible. Then we start moving over to the next stage, which is what we call mid stages, because typically there's no set, you go from development to test to UAT to production. That's one pipeline. We've got many different ways of doing it, so we refer to those as the middle stages. What this stage focuses on is how do we test to make sure that the code is doing what it's supposed to do and not actually breaking. So here's where you start looking at the dependencies. We start looking at how to package and build the actual software that we're dealing with, that keeping track of all the different dependencies, make sure that we know that we don't have a sprawl of different dependencies as well, in terms of like 50 different versions of the same dependency type scenario. Then when we start looking at production, then things start getting very interesting. There are a couple of stages to our production environment. So the first one is what we call beta, which is internal, which is effectively the wild, wild west. You can deploy there. If it breaks, it's not a problem. It rolls back. There are ways we're doing it. Typically, you don't get upset if someone breaks this. The whole idea here is that we can run a lot of testing, including destructive tests, which really damage the environment and break data and corrupt data, to make sure that the code is working. And the reason for this is that before we get the code to production, we are looking for a specific reason to say this code is not ready to go to production. We want to make absolutely sure that this code is of the highest quality and actually meets what we need. Then what we do is we start deploying to what we call our Gamma environment, which is an isolated production-like. Because remember, simulating production at the scale that we would deal with is virtually impossible unless you send all the traffic to an exactly similarly sized environment with everything being the same, which is a little bit difficult at this scale. But what that allows us to do is to run integration tests and do full end-to-end testing with data, and also still, once again, go look at, does our code behave the way we expect it to, and did it do what it's supposed to? And then when we get to production, it's not a case of throw the code out there and boom, everybody gets the new version. No, there's actually quite a lot of deployment nuances to this. You might have heard the term canary deployments, where what you do is you bring the new version online in production or deploy it first and hide it behind a feature flag, like Sasha mentioned. And then what you do is you start sending a small portion of your traffic to that specific new version of the code. Now, remember, at this point, we haven't deployed the code everywhere yet, because we're not yet sure that this code behaves the way we want to. So you deploy it in small batches to small subsets of servers, and you send a small subset of traffic to it. Then what you do is you give it time to what we call bake. So you send it through, keep an eye on the performance of the API, keep an eye on the error rates, even customer feedback in terms of customer bugs log and all of those things. And you keep an eye on that and make sure that things are not working. And then based on this, we gradually, in automated fashion, start increasing the number of people that have access to the service in terms of the traffic, and also how we deploy to different sets of servers or fleets of services. And what this has actually gotten us to is a point where we think it actually works really well. So I went and got the latest stats that we have public available with regards to our deployments. What you can see over there is that Amazon, and remember, AWS is a separate company to Amazon, but obviously there's some ways that we work together. But between the two of us, we have more than 194 million deploys a year, which means more than 6 on average deployments per second over the last 30 days when we did this stat when it was taken. So what this has enabled us is that we've got a lot of these individual small autonomous teams that are able to build and ship their own code without breaking things for the greater scope. And if they do have some kind of mistake in the service or the code that they wrote, there are ways that we catch it earlier and actually work it. And that's kind of where the DevOps philosophy and culture comes. Is like a lot of tech, a lot of people changes, and a lot of thinking about how to work all of this together to get to the end result, which is delivering code faster, but also more safely and make with less bugs. And with that, I want to say thank you. I hope you found this useful. If you do want to learn more about various AWS related things, please give me a follow on Twitter or LinkedIn. Also a bunch of live streams that I do. And also there is a Africa-focused Slack community that you can see the URL for at the bottom there if you're interested more in AWS. Like I said, I don't want to do a AWS sales pitch today. So hope you found this useful. Thanks.
All right. Thank you so much for that talk, Cobus. So fun. So our next speaker is our very own GitHub developer advocate here, Brian Douglas. So Brian, take it away.
Excellent. Thanks so much. And yeah, I'm happy to be here. I'm happy to be talking about the GitHub API. That's what I'm going to be talking about actually for the next couple slides. So this talk's going to be focused around a bit of DevOps, a bit of automation, and a bit of sort of API integrations and building that. But I'm gonna go ahead and jump on and talk about something I like talking about, which is hip hop. I really, since quarantine, I've been watching a lot of documentaries on Netflix, and I caught up on this hip hop evolution documentary. And I bring this up because with hip hop, I'm going to assume most people have heard of hip hop and rap music. If you haven't, definitely check out the this documentary series on Netflix if you can get it. But also listen to some hip hop. This is me trying to sell rap music on a GitHub live stream. But I bring this up because in this evolution, in sort of this history of hip hop, we find out that hip hop itself was nothing but sampled disco tracks. So disco being the music of the 70s kind of really came to fame in New York and other urban centers and all across the world. And I bring this up because one of the hip hop groups, one of the original groups, was called Grandmaster Flash and the Furious Five. They took disco and they even took like the disco style and popularized that into hip hop and sort of like had that transition happen. And I bring this up because so this song, this group in this song, The Message, I'm not actually old enough to be around when this song came out, but I got really into this around the Napster days when I was downloading music. And I got really involved in the song because the song, The Message, it's a social commentary of what was happening in the upper part of New York, just above Manhattan, the Bronx. And the song goes, actually, I'll sing it, but I don't think we're going to DNCA or anything like that. But it goes, my brother's doing fast and my mother's TV says, watch too much, it's not healthy. So like that was talking about how sort of the oppression, and not even oppression, just sort of the environment that the Bronx was going through at the time. There's a lot of fires, a lot of underprivileged things happening. And I bring that up because you probably never heard that song. You probably heard the hook, which is "Don't push me because I'm close to the edge." That hook was actually pretty popularized in the movie Happy Feet, which I know it sounds pretty random, but what's even more random is me mentioning Tupac. And Tupac being the sort of prolific gangster rap artist in the early 90s, mid 90s. I bring him up because he had a song called Two of America's Most Wanted, which most people don't know the title or even the song, but you probably heard the hook, which is Ain't Nothing But a Gangsta's Party, which like, again, I've seen the song and I don't think YouTube's gonna use the algorithm to find that we're singing copyrighted songs, but we'll take the chance, I guess, on the GitHub YouTube. But I bring this up because this song and all that randomness this is talked about came out in 1996, and this is the same year that REST was given to all developers. So at the University of Minnesota, the first spec for REST APIs was given to us. So I'm gonna move on from hip hop and give it a rest. I'm gonna mention GitHub. Y'all are probably familiar with GitHub. I work at GitHub. We're a collaboration platform. You should have to check it out if you sort of navigated to the stream and not even sure what's going on, or what a hub or a Git is, definitely check out GitHub.com. We've got good information there. I'm a developer advocate at GitHub. This is all my information you really need to know about me. My Twitter bio pretty much explains what I do, as well as my GitHub bio too as well. So if you go github.com/bduggy, you'll find out about that. But I'm a developer advocate, but I like to say that I'm actually a Beyonce advocate. Queen Bee, GitHub has 50 million developers worldwide using the platform, which is like an amazing number. And Beyonce has more than that listed there on her platforms. So I like to use that analogy and say that I go to bat for the hive. So I do a lot of things, and I do a lot of projects to encourage people to use GitHub in unique ways. And yeah, so that's it. Oh, sorry. Can you ask your mom real quick? Yeah, go ahead. Sorry about that. It's early here in on the West Coast of the US, so my son is just waking up. But I bring this up and all these numbers and correlations to 2017. 2017 being the year that GitHub adopted GraphQL. We sampled GraphQL as part of our API spec. And there's a lot of reasons for this, and I'm going to bring this up in my use cases. But GraphQL has really sort of helped these two pillars that the GitHub API has really been focused on, which is making it easier for integrators to integrate with GitHub API and the platform, but also provide flexibility in the way you interact with them. If you didn't know, GitHub, it is a platform. Like, we're more than just Git, we're more than just collaboration. It's all about just getting your code to production as fast as possible, and then also engaging that code and making sure your test pass. And if you have GitHub Actions, we'll talk about that coming after mine. But really what this summarizes, better hooks. And I started off this whole talk with mentioning popular hooks, because these popular hooks also correlate into the hooks into our API. So some things that we noticed with REST API, with the GitHub REST API, which I do want to mention that GitHub is about almost about 13 years old. It's about 12 and a half years old at this point. And the GitHub API is about 12 and a half years old. So GitHub.com was actually shipped, and a month later, we actually had a public API available for everybody to use and consume. But when you go 2.5 years, and as we saw with Cobus and how teams had to collaborate, you want to make things that are easier. But we found with the API that there was just inconsistencies. Like, you're going to have someone who worked on the API for a couple of years, they move on to work for another company, someone else makes the design decision, and you have different versions of the API. So this is actually an issue inside the our SDK, which is RDK, and talking about inconsistency in how you leverage the endpoints and what sort of response value gives back to you. And another hook that I like to talk about is the documentation. And the documentation for GitHub API, well, I guess I mentioned every time I learned how to use a GitHub API or use it for a new project, I always had to ask the developer sitting next to me, because that was the best way for me to get documentation on how to use GitHub's API. And this is like prior to me working at GitHub. I would say the documentation is really good as long as you know what you're looking for. We've done a lot of really good, awesome things this year in open sourcing the documentation, as well as migrating into some quick starts and having more interactive functionality with the documentation. So it's definitely worth checking out today. But at the time in 2017, it was just a giant reference documentation for API endpoints. And the beauty of using something like GraphQL is you get something like the GraphQL Explorer. If you haven't used GraphQL, actually in the chat, if you use GraphQL, let me know. I've got the chat open so I can see. Let me know if you're using GraphQL and if this is engaging for you. But what I'm going to mention is with the Explorer is you actually can interact with the data. So this is me actually querying for one of my repos. And you can see that I'm getting the data directly, and I can test the data and have like a nice little sandbox to be able to see what sort of data comes back to me, as well as you have inline documentation, which is pretty nice as well. So if you haven't tried the GraphQL Explorer, definitely check it out. It's linked in docs.github.com. You can find it pretty quickly, just looking for the GraphQL page. And back in 2017, and this is, I've only been getting GitHub for 3 years. So 2017 was like right before I joined GitHub. Coincidentally, I was really heavily involved in the GitHub API and building things. So I joined GitHub as a full-time employee. But I mentioned this because I was building a project because I wanted to test out the GraphQL API. GitHub was the first public GraphQL API to be launched, actually at the time when the GraphQL spec was in alpha. And so I built a project, and it was inspired by what I like to call the Burna Boy of trap music, Gucci Mane. I say Burna Boy because I know we had a lot of Nigerians in the house. But Gucci Mane, he's a prolific artist, a rapper, sampler, and and he actually sampled the song "Loving You" by Minnie Riperton. It goes, "Loving you is easy because you're beautiful." Actually did that. It's a pretty intense song, so definitely listen to it at your own discretion. But I bring up Gucci Mane because he has this quote from the mid-2000s, which if you don't got sauce, then you lost. And I wanted to build a project that helped me do open source. I built a project basically to help me do open source and manage my open source projects. And that's what this looks like, which is called open source, which is where the Gucci Mane quote comes in. Okay, it looks like I have the audio. It seems like a bot voice. Interesting. Not sure if that's something I can fix on my end.
All right. So you should probably hear me better. It looked like my mic was actually set to a different mic, so this should be better. Sorry about that, folks. But we're gonna power through. All right. So if you miss all the other portions of this, I did do a. Actually, I've given this talk before, so if you definitely look up Brian Douglas in GraphQL on YouTube, you'll actually find the whole intro part. But if you missed the audio, so I'm not sure how great this video is going to be after the fact. But I actually, if I go back, I was talking about the GraphQL API as a better way for hooks into documentation, into integrating with the API. So if you missed that context, I'm happy. Hit me up. I can definitely give you a link to the video series of me, or the YouTube video of me explaining this before. But what I really just want to get into is I built an integration using a GitHub app and the GitHub API, which actually helps me build better integrations to finding out how to contribute to open source. So that's what this is. And I had mentioned earlier too, when my voice was actually pretty messed up, that I was just looking to integrate with the GraphQL API. And the way I did this is I built a React app that is actually powered by Relay. It's no longer actually, this is an old slide. It's no longer powered by Apollo, but when most people hear about GraphQL, they hear about Apollo as the way to consume GraphQL API. And this entire project, which is open source, is powered by GitHub issues. So my entire backend is powered by GitHub issues. And the way I did that is I built a GitHub app, which I'll talk about in a sec. And I integrated that with this open source tool called Auth Guardian, which takes my GitHub token and my GitHub app and gives me GitHub data. And also gives me a way to leverage a tool called Relay, which is to be able to persist queries, which is, if you don't know about GraphQL, if you don't know about persistent queries, definitely just give it a Google. Also, if you YouTube persistent queries on YouTube and just type in Brian Douglas, you'll see another video of me actually explaining in way more depth on this, as well as talking about hip hop as well. I'm a big hip hop head. I like talking about hip hop. But the beauty of this is like with Relay being a tool that basically consumes your GraphQL API, it gives you a way to cache your responses. Because one thing I'll bring up is that GitHub has a rate limiting. It does have rate limits because we do have 50 million developers worldwide using GitHub. We want to make sure that no one's abusing the platform. Just like folks on YouTube poorly singing rap songs, which honestly, I'm kind of glad my voice was kind of messed up earlier because you missed all my rapping earlier, probably. So this is me basically. If you look at line, it's about line 4. I'm actually taking my GitHub token from my GitHub app, and I'm embedding that into my project. And then with that embedding that GitHub token, I'm able to access all the GitHub data I need to make my app work. So as I mentioned and alluded to earlier, you can improve your developer experience through GitHub apps. So GitHub apps allow integrators the flexibility to get the better hooks into GitHub's platform. Now, shout out to Probot. Probot is a tool to create a GitHub integration really quickly. If you go to probot.github.io, all the documentation is there for you to sort of integrate basically pretty quickly. They've got a nice CLI tool to not only generate your GitHub app from the command line, but it also integrates it and gives you the token directly. So you can just get started rather quickly, actually. I'm going to shout out to like all these videos I've done on all the stuff I'm talking about, because there's a serverless probot video that I also have on YouTube. If you just type in serverless probot, you'll see how to get a GitHub app up and running pretty quickly as well. So hopefully, even though you lost some of the context in the first like 15 slides, hopefully you'll just Google my name and you'll find all the context for all this information. But I did want to talk about automation and workflows using the GitHub API. And so there's some tasks that you do repetitively, like things like deploying, like getting stuff into production, getting stuff into staging. There's some things that you do that are not even dependent on Git, like actually dependent on Git with your pull request. But like some things I do is I review pull requests once a day. I have an open source project, which I mentioned, open source. I like to review pull requests once a day to make sure people who are engaged and committing code, they get feedback and reviews from me pretty regularly. And the way I sort of automate myself into reminding myself to review those pull requests is I set some automation. I actually leverage Discord, so I have automation. So whenever there's an open PR, it just pings me and lets me know that, hey, there's a PR so open, ready to review. Go ahead and take a look. So as I mentioned before, listening to hooks, having hooks into the GitHub API, and through these integrations. I have another example, which one of my former colleagues actually built integrations. Whenever new issues opened, you can leverage a bot or a GitHub integration to add a needs response label to your issue, which it sounds trivial, but sometimes automation could just take away the seconds or the minutes of you just trying to figure out what needs a response just by adding a label automatically. So that's this actually happening. I do want to point out that I mentioned in the first half of the talk that GraphQL exists, the GraphQL API. One of the first public GraphQL APIs back in 2017 was GitHub. It's still the most prominent, to be quite honest, when you talk about public APIs. But it was also powered with this tool called OctoKit. OctoKit being an SDK for you to interact with the GitHub API and not have to rebuild the same stuff that you would need for this app or that app. Probot and OctoKit are tools for you to basically get off the ground running really quickly. So this is an example of me adding a label for the previous example that I showed you with Bex, adding a label that says need response. So definitely check it out. Again, all this is, if you Google my name, B-Dougie, and any of this information, you'll probably find examples and blog posts of me explaining this as well. The GraphQL API provides opportunity to define interactions based on solutions and not endpoints. The one thing I didn't bring up too, as well as I was fiddling the mic, is that usually with REST endpoints, you have to hit multiple REST endpoints to get issues, to get comments, to get user data. It's going to be like 4 or 5 different endpoints just to do one integration. The beauty of GraphQL, you only have to hit one endpoint, and that's the /GraphQL. So it's literally api.github.com/GraphQL, and that's all you need to be able to define the data you want and to receive that data back in this. So one of the things I do pretty frequently is try to find out all the contributors for my organization or my repos. And this is actually a GraphQL query that will, if you did copy and paste this, it will work. You can copy and paste it in the GraphQL Explorer. Just replace it with one of your repos, and you can actually see all the contributors for your repo. So definitely check that out. So I bring this up, and again, apologies for the mic mishap as well. I should have definitely checked that earlier, but you could sample GraphQL today by using your own GitHub data. The beauty of this is that all you need is a GitHub account. You just log in with your GitHub account into the GraphQL Explorer, and you can start testing out data. You have a sandbox to basically see what data you can do and what integrations you can make happen too as well. I do want to point out there's integrations with GitHub Actions that use GraphQL as well, so definitely check those out. Again, it's a quick Google. Use the GraphQL Explorer to explore the Git sampling, which if you miss all my puns and all my hooks in the beginning, it's all about sampling GraphQL using your GitHub account. I did allude to all the videos that I created on YouTube that cover this content. I just go by B-Dougie on YouTube, so just check that out. I also, some of the focus of my GitHub action videos and doing automation are focused around this one interaction, which is a GitHub action to take action. So it literally, it gives you a way to assign yourself to issues, despite the fact if you're part of the org or not. If you've ever built an integration or if you manage an open source project, you know that as a maintainer, only maintainers and collaborators can assign themselves to issues. But I built an action to basically let anybody assign issues. It was super helpful during Hacktoberfest when I actually was getting a lot of contributions. So I encourage you to check that out. Check out all the links. And I'm happy. You can find me pretty easily on on Twitter or GitHub. Just looking for BDougie or BDougieYo on Twitter. I did want to also shout out GitHub Universe is happening next month. So if you have not heard about this, we have a free event next month where we'll cover all the new features for automation and DevOps and GitHub, GitHub features as well and collaboration. It's a free event. You might as well just add it to your calendar, sign up. It'll be definitely rebroadcasted right here on the YouTube channel. So definitely hit the like and subscribe and all the notification bells. And with that being said, I'm BDougieYo. And again, thank you very much for struggling with me.
All right. Thank you. Thank you, Brian. That was a great talk. So if you're just joining us, this is the African Meetup event. And we've been talking a lot about DevOps. We've had someone from GitHub talk about an introduction to DevOps. And we've had another person coming from AWS talking about introduction to DevOps on AWS. So the next speaker is Anita Ihuman. Anita Ihuman is, a student from Nigeria, and she's passionate about open source software development. So I'll let Anita take over once she's ready.
Hello, everyone. Nice to meet everybody. I'll quickly share my screen. Okay, I'm Anita Ihuman, a React developer and technical writer and a fan of open source. I started my journey like 8 months back. Yeah, 8 months. This month's maybe 8 months. And so far, I've had a lot of fun. And I'd like to share with you how to automate workflows using GitHub Actions. Okay, GitHub Actions are a set of instructions that make it easy to automate all the software workflows. And it is responsible for carrying out the tasks of building, testing, and deploying codes from GitHub. GitHub Actions also provide the facility to build end-to-end continuous integration and continuous delivery, just like Sasha talked about in the early talk. Yeah, it's okay. The core concept of GitHub Actions, we have the events. Yeah, so events are specific activities that trigger a workflow run, and events can vary ranging from pull request to push made to repository. Those are all called events, and they're triggered when someone makes a pull request or a push to a repository. Then we have the workflow. The workflow is an automated process that is made up of multiple jobs, either one or two, or multiple jobs. So you make this happen by creating actions in a repository. And workflows can handle the common build task like continuous delivery and continuous integration. And the workflows in a laid out instruction is in usually in the YAML file of the GitHub workflows directory. The jobs refer to the tasks in a single workflow, and they're made up of multiple steps and runs in an instance of the virtual environment. It contains more than a workflow could contain more than one job, and it requires for all of them to be complete, or there will be no execution. So why GitHub Actions? Yeah, GitHub Actions came into play like 2019. Yeah, about this month, 2019. And since then, it's been a trend since then, because yeah, they help fix a lot. They help fix a lot of issues. Yeah, they're readily available. They have readily available code. So if you want to automate a step manually, you can do that. But they're like scripts on the marketplace on GitHub where they're like different actions for different purposes. There are varieties, it works for varieties of languages. This is even more cool. So whatever language you're coding in, GitHub actions are always ready to like kickstart. And you can use it for, it works on cross-platform compatibility. So you can use it for most hardwares and hardware OS environments such as Ubuntu, Windows, and Mac OS. GitHub Actions, they're built in GitHub, which makes it a lot easier instead of moving your files from one place to another just to like deploy it. GitHub Actions are fully integrated into GitHub and therefore doesn't require any external site, and everything is in place and makes it super convenient. They have a great free plan because everything about GitHub Action is basically open source, so you can kickstart without even paying a dime. Multiple CI templates, and they provide several templates of CIs of various technologies that you can use easily in integrating your code. I like to do a little demo, so please follow along. This is my repository on React to do, and I'd like to show you how to automate GitHub actions like in a very snappy manner. So first off, you will locate your actions in the repository, and you see like several actions here. There's one for Node.js, Deno, and if you go down, there are like several other options. So whatever you're working on, you can see PHP, Ruby, Rust, that they're all available. But I'll be using the Node.js because I'm working React. Yeah, and the code is readily available, just like I said earlier. So we have our code already here, and we can choose to change the name. So I'm going to rename it test, and over here too, I change the name to test. This on here is the name of the work. The on button is a keyword that defines GitHub event. So you could, this particular workflow now is going to be responsible for pushes in the branches, and then the pull requests that are made to the master branch that is specified here. And if you want to change it from the master branch, then you could do that. But I think since it's just a test, I'll leave it at that. And then job run. The workflow run is made up of one or more jobs, like I said earlier. So this, everything underneath here is responsible for the actions that are going to take place. And the metrics, this metrics here is specified the operating system which is going to be working on. The run specifies the operating systems, and then the metrics tells you the version of the node we're working with, and that is just about it. And every other thing is just responsible for the actions taking place. And yes, that's a commit. Okay, I think I just agreed. Yeah, so it's already in my repository, like you can see it in Git under workflows. So let's see if it works. I'm going to do a few tweaks to the code. Yep. Let's see if it works. And let's see how it works. Okay. Yes. Okay, I'm going to commit the changes now. All right. Okay. This one, apparently it did work. You can see it's giving me the test already, and the checks are actually ongoing right now. Yep. So for a few more touches, you could go to your settings. Hold up a bit. So these are the options you could indicate on how you want the actions to work. So if you require a signed in, include administrations, pull request review before merging. Okay. Yep. And that's it. Well, that works now. Or some checks are already failing. So this is basically how you could fix your GitHub actions and get everything kickstarted. If you're running a project and you're too tired to have everything sorted out, this is exactly how you get it done. GitHub actions. Yes, that's just all I have to say. Thank you very much for listening. I'm Anita Ihuman, and you can check me out on Twitter at Anita_Ihuman. Thank you.
All right. Thank you, Anita, for that demo on GitHub Actions. And I would just like to point out that there's a ton of free GitHub Actions you can start with. You can go to the GitHub Actions, the GitHub Marketplace to check out so many GitHub Actions that you can use or make your own, like Anita was showing us there. So thank you so much, Anita. So the next speaker, we'll be talking about GitHub packages. So let's welcome Maye Edwin to give us a little bit of GitHub packages. Maye, over to you.
Hey guys, I am Maye Edwin, and I'm very super excited to be speaking to you guys today about GitHub packages. And just before that, I'm a software engineer at Sky.Garden and actually very active on Twitter. We can always have a chat via at Maye Edwin1 about open source web developer communities and GitHub packages, right? More about me. So I'm passionate about community building and also GDG community organizer. I know most of you have heard of GDG program by Google developers. And to add on that, I'm also a tech speaker. So I've been able to speak back here and globally at various conferences. And I just love sharing knowledge and what I learn every day, and anything I might know that I think will be beneficial to whichever audience I receive. So basically, I speak to software engineers and any tech-related topics. And to add on that also, I'm an active open source contributor and currently actively working on pwfire.org, which is basically resources for developers who want to build great user experiences with progressive web apps. So all the resources you need, tools and extra. And also, just to add on that, I actually co-author it with a friend of mine who is based in Poland, and it's been actually a very exciting journey for us, contributed in that domain, that is progressive web apps. So you could check it out at any time, have a look at it, see if it's something you could use to build powerful progressive web apps, and also actually support us by sponsoring us or even buying us coffee. So basically that is it about me. And just like I said, we're going to have a very, very lightning talk about GitHub packages. So basically the why, the need, and most importantly, why building this into the GitHub developer ecosystem is something that GitHub has really done very amazingly. So just to kind of discuss the basic understanding of packages. So when I speak about packages, I know you guys already know what packages are. So we've interacted with a few packages, or many of them, through different package registries, and GitHub packages is not different from them. Okay, so from a low level understanding of packages, so they're basically reusable pieces of components. So think about a situation where you are working on a website and you have this website being designed in a way that it has buttons, sections, asides, and all those elements within it. So there's a component like the header, the footer, the buttons that will be very repetitive across pages that you may have within your project. So if you're working in an organization and would like to kind of have a consistency in your design ecosystem within your organization, you will publish this one as a component. Okay, so you could do that on GitHub package registry, and so everyone within the organization can install. And in that sense, there's some kind of consistency across the entire organization for all the project that uses it. So that is just a basic understanding of how packages evolve. So it's basically a way of exposing reusable chunks of code or pieces of functions within your project and being able to share it internally within your organization, various projects you use, or share it outside the organization that is open source and publicly, and allow people to kind of consume it. And that is just so amazing. And the entire idea around packages, it's actually building on top of GitHub's mission, which is allowing millions of developers to build great software together. And it pushes forward the need to share, build together, and allow people to declaratively build software wherever they are, and be able to access these chunks and make their software development experience very, very exciting. And that is just very, very, very important for any software developer. And very important things we are going to discuss about why GitHub packages, to be specific. So you are able to host your packages with your code. So that means everything is within GitHub ecosystem, just like I said. So you host your code and packages in one location. So basically the GitHub ecosystem, and you can actually be able to consume them within your organization, what I call internal open source. So between teams, if you're working in a large kind of organization that has so many projects within, its ecosystem, and that is just really excited about it. Yeah, and there's this secure login built around the same. So the same way you access your private repos, the same way you'll be able to access these private repos for your GitHub packages and stuff. So also being able to build your packages on top of already existing excited GitHub developer toolings. So the workflows, the actions, so being able to build, test, and deploy on the go your GitHub packages together with your source codes or your entire projects that actually would consume these packages. And interestingly, there's nothing changing about the package ecosystem around GitHub packages. So you could actually directly download them or even access them via the global CDN. And that is it. Yeah. And maybe to dig deeper on how you could maybe think of like, okay, how do we publish? So nothing is changing. So maybe to publish your reusable chunks or packages to GitHub. So the normal thing you will do is you have to authenticate. Yeah. And then after the authentication is done, you're able to kind of publish your package on GitHub. Yeah. So and share it privately or publicly. So what we'll do in your package.json is you just add a publish config. So you specify the registry, which is the GitHub registry, and then authenticate. And before you authenticate, actually you need to have a personal access token within your environment, your local environment, to be able to authenticate, and then finally publish, okay, by just running npm publish, and you publish it to the GitHub registry here. And that is it. Very quick, yeah. So the same way you've been doing publishing with other registries, nothing is actually changing, but the the exposure to these amazing tools built within the GitHub ecosystem gives it a plus. So you don't need to separate your source codes in different locations or different services. So you have everything on GitHub, the same logins, the same automation workflows and actions, with actions definitely, and the same testing. So you see, so it just provides you a way to even build even much better, well-tested and managed GitHub packages, yeah. And that's so interesting about it, yeah. And personally, I've also published one. So like, for example, the number sort, and people could easily also have it easy installing. So just run npm install from your environment, install the specific package you want to install, or you can put it declaratively into your package.json in whichever project that is using it, and that is it. You're ready to go. So easy to publish and easy to actually use other available packages on the GitHub community within the ecosystem. Yeah. So basically that is it. And one important thing I was talking about is security. So you can install private and public packages on the go without worrying about how safe are these packages. And you can also manage how people or developers actually consume packages for your project within your organization. So you can approve those that actually need to be installed and those that are not really needed to be. So there's these kind of DevOps also been brought into the entire workflow of publishing and consuming packages with GitHub packages. And also, just like I said, actions, automation. Yeah. So continuous development, continuous testing, continuous deployment. Yeah. And you don't need to worry about that once you set up, and you don't need to build different workflows. You could actually build single workflows that could be used for the entire project or specific packages that your teams use or you individually use for specific projects. And yeah, just to kind of wrap around the cloud automation capability. So actions, so you build, test, and deploy. So you can set that up, test, install automatically when a new version, for example, is up. And yeah, time authentication for all the automated package uploads and downloads through GitHub Actions. So building or publishing packages on GitHub now provides you an ability to easily manage, test, deploy, and build these workflows that allow you to build even much safer and even much more high quality, kind of packages for people to consume, or you personally to consume within or outside your organization. And that is it, guys, about GitHub packages. And yeah, all I'll say is, people, go build and explore GitHub packages and see how that will actually work for you. But I can promise you that you can see there's a lot that publishing into the GitHub registry allows you to build on top of. So access to these automation tools, better testing, and all those things, and being able to kind of bring some kind of DevOps, managing on how people actually install and consume packages for your projects in your organization. And that is it, guys. Thank you so much, and I hope you enjoyed, and feel free to also explore my open source projects on GitHub. And yeah, let's have a chat anytime, any day. Thank you so much.
All right, thank you so much, May. We appreciate that talk on GitHub packages. And thanks to all the speakers today, from Sasha to Cobus to Brian, Anita, and May. Thank you for all the valuable information you gave us today. But we're not done yet, so don't run away. Before we go, I just want to give a few closing remarks and some announcements. Specifically, I just posted in the chat. You can give us feedback on these meetups, what you want us to talk about for future meetups. You can go in the YouTube chat and see specifically what. You just give us your feedback, and want to hear from you. The purpose of this is to connect with our African developers, because we've seen a lot of contributions to open source work from developers in Africa. So we want to meet with you guys. We want to hear from you, and we want to be there for you as much as possible. So do make sure to fill out the survey that I just posted in the chat. And so another thing I want to mention is that the next event is not going to be a meetup like this, but it's going to be our annual developer event. It's called the GitHub Universe event, and it starts from December 10th to December 8th. There's going to be a lot of speakers. There's going to be a ton of ships. So do make sure you go to githubuniverse.com to look through all the all the different speakers that will be presenting, and choose if you have a favorite topic you want to attend. Definitely go check it out, and you can easily just add it to your Google Calendar or whatever calendar you use, so that you're reminded when the event is live. It will be on YouTube, it will be on Twitch. So definitely check out the event. And also after now, we'll be having a breakout room on Zoom. So definitely join us on the breakout room. We would post the link to join us on the Zoom meeting. We just want to talk to you guys. Brian Douglas, one of our developer advocates at GitHub, will be there. I'll be there, and I think Erin is also a GitHub employee. She will also be there. So we want to talk to you guys. We want to have a chat, and we want to make sure that we're taking care of our developers in Africa and all around the world. And there are meetups like this all in different regions around the world. So thank you so much. Make sure you tune in for the GitHub Universe event and have a lot of fun. So I'll see you guys in the breakout room. So thank you so much. Have a wonderful rest of your day, morning or afternoon or evening. All right. Thank you, guys.